In Jinan, in eastern China's Shandong province, there is a factory floor that used to produce 12 million tons of steel a year, enough to rank among the 10 largest steelmakers in the entire country. Today, that same floor holds 20-ton vibration test stands and anechoic chambers built to test radio equipment in complete silence, and the people running the machines are, in many cases, the exact same workers who used to run the steel mill. Electric welders who once fused massive steel plates have been retrained and certified in space-grade welding. Maintenance mechanics who once kept blast furnace equipment running have been retrained as satellite assembly technicians. At the beginning of 2026, the first satellite rolled off this production line. The facility now has the capacity to build 100 of them a year. The company is called Jigang Group, and satellite manufacturing was never supposed to be its business. It spent over 60 years as one of China's most important steel producers, and it did not choose to leave that industry because steel stopped mattering. It left because China had built too much steelmaking capacity, and Jigang was one of the companies caught on the losing end of the government's own effort to fix that problem. What it did next, converting an idle industrial giant into an aerospace manufacturer capable of building 100 satellites a year, turns out to be one small piece of a much bigger, much stranger national pattern happening across China right now. A satellite manufacturing build-out so large that the country's factories can already produce more spacecraft in a single year than its rockets can actually launch, by a margin that gets more surprising the closer you look at it. By the end of this video, you will understand exactly how a steel mill becomes a satellite factory, why China is building manufacturing capacity years ahead of its ability to use it, and whether that gap is a mistake or a deliberate bet. If you like videos about the technology quietly reshaping how the world works, hit like and subscribe so you do not miss what is coming. Let's start with why a company this deep into steel had any reason to leave it behind at all. Jigang was founded in 1958, and at its peak, it was not a minor player in Chinese heavy industry. The company ranked among the country's top 10 steelmakers and was, at one point, China's single largest production base for medium and heavy steel plates, the thick, structural steel used in shipbuilding, construction, and heavy machinery. For decades, that was simply what Jigang was, a genuinely important pillar of the regional and national economy, employing thousands of people in one of the most physically demanding, capital-intensive industries in the world. Then China's steel industry ran into a problem that had nothing to do with demand for steel disappearing and everything to do with there being far too much of it. Through the 2000s and early 2010s, Chinese steelmakers, encouraged by cheap financing and local government incentives to keep production and employment numbers high, built out far more smelting and rolling capacity than the domestic or export market could actually absorb. Steel mills kept expanding because shutting down was politically costly and cheap credit made expansion easy, even as the gap between capacity and demand quietly widened year after year. By the mid-2010s, the country was producing steel it could not profitably sell, prices had collapsed, and entire regional economies built around steel towns were sitting on factories running well below capacity or not running at all. Beijing launched a nationwide supply-side structural reform campaign specifically aimed at shutting down excess industrial capacity in steel, coal, and a handful of other bloated heavy industries, even when that meant closing plants that were still technically capable of operating. Jigang's main steel operations were caught directly in that reform push, and the company shut them down, leaving behind exactly what you would expect from a conglomerate that size: enormous tracts of industrial land, hundreds of thousands of square meters of factory space, and thousands of skilled workers with nowhere left to apply that skill. That is the exact moment Shandong province decided not to simply let that capacity sit idle. In 2019, the provincial government signed a cooperation agreement with the Chinese Academy of Sciences, specifically targeting what Chinese policy documents call the conversion of old and new growth drivers, a deliberate, government-coordinated push to redirect capacity stranded by industrial reform into newer, strategically prioritized sectors rather than simply writing it off as a loss. Jigang seized that opening and forged a partnership with the Aerospace Information Research Institute, a division of the Academy of Sciences, and made aerospace manufacturing its new primary business. As Jigang's general manager, Xu Qiang, put it, the goal was never simply replacing one industry with another. It was redirecting the company's existing production capacity, its land, its buildings, its workforce, toward what Chinese industrial policy now calls New Quality Productive Forces, essentially the government's term for the next generation of strategically important, higher-value manufacturing sectors it wants the country to lead in. The scale of what actually got repurposed is worth sitting with for a moment. Zhejiang converted part of its 5,700 mu of industrial construction land, roughly 380 hectares, and 810,000 square meters of existing factory space into satellite assembly workshops and rocket testing facilities, all built on top of infrastructure originally designed to move and shape enormous quantities of molten steel. More than 3,000 of the company's skilled workers were retrained and transitioned into aerospace roles, and the retraining path Xu described is not a small leap. Welders who spent careers on steel plate seams passed formal assessments to qualify for space-grade welding, precise enough for hardware that has to survive the vacuum and thermal extremes of orbit, and mechanics who kept industrial machinery running were retrained specifically as satellite assembly technicians. It turns out the underlying skill set, precision metalwork, complex mechanical assembly, rigorous quality control on enormous industrial equipment, transfers a lot more directly from steelmaking to spacecraft manufacturing than you might expect. The industry changed completely. The specific expertise that made someone good at their job did not have to. What actually exists on the ground today is the Jinan Satellite Assembly, Integration and Testing Base, a facility capable of full-process manufacturing and testing for both communication and remote sensing satellites weighing up to 500 kilograms each, with an annual production capacity of 100 satellites. The first satellite rolled off that line at the start of 2026, and as of this video, the company has already secured orders for 12 satellites, with plans to build at least 20 more before the end of the year. Zhejiang did not stop at satellites either. On a separate 168 mu section of its former industrial land, the company built a dedicated test base for liquid rocket engines and rocket propulsion systems, now operating 20-ton and 100-ton dual-position engine test stands alongside a 600-ton liquid rocket propulsion system test stand, and that facility is not just serving Zhejiang's own hardware. It is providing testing services to outside launch companies, including Deep Blue Aerospace and CAS Space, meaning a former steel mill in Jinan is now quietly part of the testing infrastructure other Chinese rocket companies depend on to get their own engines flight certified. As remarkable as Zhejiang's transformation is, it is not actually the exception in China's current satellite industry. It is closer to the norm, and seeing the full scale of that norm is what makes Zhejiang's story land differently. A survey by the Chinese space industry outlet Hello Space, cited by the trade publication Space News, found that China has built or is actively building dozens of satellite factories nationwide, with a combined theoretical output exceeding 7,000 spacecraft a year once every planned facility comes fully online. That is not a hypothetical future number either. Operational plants already running today can collectively turn out thousands of satellites annually, with additional facilities still under construction expected to add substantially more capacity on top of that. Some of these factories match or exceed Zhejiang's ambitions outright. In Wuxi, in Jiangsu Province, a company called Guoyu Starry Sky Technology, a subsidiary of Beijing Minnospace Technology, operates what state media describes as the province's largest and most intelligent satellite mass production base, built with roughly 1 billion yuan of investment, close to 147 million US dollars, and capable of turning out more than 150 satellites a year, each weighing between 200 and 500 kilograms, spanning optical remote sensing, radar imaging, low-orbit communication, and navigation enhancement satellites. According to the facility's deputy general manager, a custom-built satellite used to take 3 to 6 months to develop from scratch, engineered individually for each specific mission. On Guoyu Starry Sky's automated, modular production line, built around a self-developed standardized satellite platform and Wuxi's dense local supply chain of component suppliers, a mass-produced satellite now takes just 20 to 25 days, with robotic arms handling precision tasks like applying thermal conductive grease and mounting delicate components that used to require careful, slow manual assembly. In June 2026, 6 satellites from a constellation called Huantian rolled off that same production line in a single batch, 4 radar satellites and 2 optical satellites, ready to launch together as a cluster rather than one at a time. This nationwide build-out is not scattered or accidental, and the geographic pattern behind it tells you almost as much as the raw production numbers do. Shanghai hosts multiple large operational factories run by state-owned players, including the Shanghai Academy of Spaceflight Technology, anchoring production specifically for the Guowang constellation. Zhejiang Province has built significant production capacity of its own. Jilin Province, anchored by a company called Changguang Satellite, can already produce hundreds of satellites annually. Hainan and Beijing are each developing additional large-scale capacity, and Hainan specifically has built its satellite production hub directly adjacent to its own launch facilities, a deliberate design choice meant to compress the entire supply chain from finished satellite to orbit into as short a physical distance as possible, rather than trucking finished spacecraft across the country to reach a launch site. Underneath all of that regional spread sits one unifying policy decision. Beijing has formally designated commercial space an emerging pillar industry, a classification that unlocks dedicated state financing, local government support, and coordinated industrial development programs, effectively signaling to every provincial government and state-owned enterprise chairman in the country that building capacity in this sector is a strategically sanctioned bet worth making, the same kind of signal that pulled a steel conglomerate like Zhejiang into aerospace manufacturing in the first place. The obvious question is what all of that manufacturing capacity is actually being built for, and the honest answer is two enormous, still partly unfinished projects. Guowang and Tianfan, China's two flagship low-Earth orbit broadband constellations, are together reportedly slated to eventually include tens of thousands of satellites, positioned as China's answer to Starlink, providing global internet coverage from a dense mesh of satellites in low orbit rather than a handful of traditional geostationary spacecraft. Add in every additional constellation Chinese companies have filed paperwork for with the International Telecommunication Union, and the long-range paper total on file climbs into the hundreds of thousands of spacecraft, though no serious industry analyst actually expects every one of those filings to become real hardware. Filing an ambitious number with the ITU costs comparatively little and reserves a claim to valuable orbital slots and radio spectrum, whether or not the satellites behind that filing ever actually get built. It would be dishonest to end this story sounding like China has already built a satellite industry to rival anything currently in orbit, because the single most important number in this entire story is not how many satellites Chinese factories can build. It is how few of them are actually reaching space. Independent orbital tracking compiled by astronomer Jonathan McDowell, the standard reference researchers and journalists use for this kind of accounting, shows China launched only several hundred satellites in all of 2025. SpaceX, by comparison, launched more than 3,000 Starlink satellites on its own in that same year, a single company operating a single constellation outpacing an entire country's satellite launch output roughly tenfold. China's satellite manufacturing capacity currently exceeds its actual annual deployment to orbit by a factor of more than 10, and the reason has almost nothing to do with the factories themselves, which are, by every account, genuinely capable of the production numbers being claimed. It comes down entirely to rockets. China still relies heavily on expendable long-march rocket variants, older hypergolic-fueled boosters, alongside newer cryogenic and kerosene-fueled vehicles, supplemented by smaller solid rockets from commercial launch startups. And none of that current fleet is reusable in the way SpaceX's Falcon 9 is. Without reusability, you cannot fly the same rocket dozens of times a year at a fraction of the cost of building a brand new one for every single launch, which is precisely the innovation that let SpaceX ramp Starlink deployment to thousands of satellites annually in the first place, launching the same handful of rocket boosters over and over, sometimes with turnaround times measured in days rather than months. Every Long March launch, by contrast, still means building an entirely new rocket from scratch, at a correspondingly higher cost and a much slower production timeline. Zhejiang's factory, and every other satellite factory being built alongside it across the country, is currently producing hardware faster than China's launch industry can actually get it off the ground, which means finished, flight-ready satellites are, in a real sense, piling up faster than the country's rockets can clear them. That gap is exactly where the more interesting, more genuinely open question in this story sits. One reading treats the mismatch as a symptom of dysfunction, evidence that Chinese industrial planning has produced an oversized manufacturing base with nowhere near enough demand to justify it. a pattern that has shown up before in other Chinese industries, steel among them, that built out capacity faster than the market could absorb it. Exactly the trap Zhejiang itself already fell into once. A different, more charitable reading, and the one favored by several space industry analysts covering this specific story, argues that the overcapacity is not a planning failure at all, but the actual strategy, executed deliberately with the earlier steel lesson in mind rather than in ignorance of it. Building satellite factories is, relatively speaking, the easier half of catching up to a company like SpaceX. Building a reusable rocket program capable of matching Falcon 9's launch cadence is the genuinely hard half, the part that took SpaceX itself the better part of a decade and multiple exploded test rockets to solve. By front-loading manufacturing capacity years ahead of the rockets needed to use it, China ensures that whenever its own reusable rockets finally do mature, and several Chinese commercial launch companies are actively racing to develop exactly that right now, the factories will already be sitting there, tested, staffed, and ready to fill the launch manifest immediately, rather than needing another 5 years of construction after the harder rocket problem gets solved first. It is a bet that idle or underused production lines for a few years is an acceptable cost if it means the manufacturing side is never the bottleneck once the launch side finally catches up, essentially betting the easy problem now against the hard problem later, rather than the other way around. Whether that bet pays off is genuinely still undecided, and it depends on questions nobody can answer definitively yet. Which of China's several competing reusable rocket programs actually reaches a real operational launch cadence, and how quickly? Whether Guowang and Qianfan's deployment rates start climbing toward hundreds of satellites per launch campaign, the way Starlink's did once Falcon 9 hit its stride, which would close the manufacturing-to-orbit gap fast, or whether they continue rolling out at the comparatively modest pace China has managed so far. And whether factories like Zhejiang's and Guoyu Starry Skies eventually find enough customers beyond the two state-backed mega-constellations, remote sensing agencies, IoT companies, meteorological services, direct-to-device connectivity providers, to keep their production lines running at anything close to full capacity, or whether some of this build-out ends up as capacity the commercial market simply cannot absorb, quietly subsidized by provincial governments chasing a strategically designated industry rather than genuine near-term demand. Zoom out, and Zhejiang's story works as a fitting symbol for that entire uncertainty, precisely because of where it came from. This is a company that already lived through one version of China's industrial cycle, building far more steelmaking capacity than the market could use, watching prices collapse, and eventually being forced to shut its main business down as part of a national correction that closed plants across the entire industry, regardless of whether any single one of them was still technically capable of running. It has now been rebuilt, quite literally on the same land, inside the same buildings, staffed by many of the same retrained workers, as a bet on an entirely different industry racing toward a very similar kind of overcapacity question, just with rockets standing in for the demand problem steel once had. Whether Zhejiang's satellite factory ends up looking, a decade from now, like the industrial backbone behind a genuinely successful Chinese answer to Starlink, or like another example of capacity built faster than the market that was supposed to justify it, is not something a single production line in Jinan can answer on its own. What happens next depends on questions that will only get resolved by watching, not predicting, which of China's competing reusable rocket programs actually reaches real operational cadence, and how fast it gets there, whether Guowang and Qianfan's deployment rates start climbing toward the hundreds of satellites per launch campaign that would finally close this manufacturing-to-orbit gap, and whether factories like Zhejiang's find enough paying customers beyond the two state-backed mega-constellations to justify running near full capacity rather than sitting partly idle, waiting for demand that provincial governments, not private markets, decided should exist. The factories exist now, tested and staffed and ready. What happens to the rockets over the next few years will decide the rest. If this video showed you a piece of the space race you had not seen coming, hit like, subscribe, and turn on notifications so you catch the next one. And here's a question for the comments. With China's satellite factories already capable of building 10 times more spacecraft than its rockets can currently launch, do you think that gap closes within the next 5 years as reusable rockets mature? Or is this the kind of overcapacity that ends up sitting mostly unused?